Boom! Alright folks, how are you going? Hume here. In this video I want to talk about a topic that is very important and central to the AdMath syllabus, and that is the topic of Surds. Actually, it will be the first of a few videos where we break it up into little chunks, little pieces, so that we can focus on each segment one at a time. I want to start off by defining what a surd is. Alright, so I went to the internet and the definition I have here is as follows. Hold on. They're saying here that a surd is basically the irrational root of an integer. Right? There are a few concepts in that short phrase. The irrational root of an integer. Alright? We discussed the whole idea of irrational numbers in a previous video, so I'm not going to spend any time talking about that here. However, in the process of demonstrating a few examples, you'll get a very clear picture of what a surd is. Alright? They spoke in that phrase about the root, and they spoke about an integer. So, let us demonstrate by first starting with what I like to refer to as perfect powers, exact powers, anything along those lines. So let me say 2 squared. We know that 2 squared is equal to 4. We know that 4 to the power of 3 is equal to 64. We know that 5 to the power of 4 is equal to 625. Right? What that means, the flip side, is that the square root of 4 is equal to 2. It means here that the cube root of 64 is equal to 4. And down here, it means that the fifth root of 625 is equal to 5. Alright? So you have exact powers and exact roots, all with integers at the helm. Right? Now, if we go to make life a little more interesting now, if I do this, if I say, what is the square root of 5? Da 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 da. What is it's supposed to be a 3 here, not a 4. Eh? Alright, this is supposed to be a 3 here. Mistake. And this is supposed to be a 4. Mistake again. Alright, nice. If I say, let me say we want to find the cube root of 70. And let us say we want to find the fourth root of, let me say, 689. Right? Just by looking at these numbers, you will know immediately, starting with the power that we're most familiar with, you know immediately that the square root of 5 will not be an integer, because the square root of 4 is 2, and the next number in the line, the next perfect square, we will come to that shortly, is the number 9, where the square root is 3. So in other words, the square root of the number 5 would be something between 2 and 3. Alright, and the actual answer is 2.236 going down the road. Alright, so the square root of 5 is 2.236 da 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 da. The cube root of 70. Right? 4 cubed is 64. And we know that 5 cubed is 125. Right? And if 70 is between 64 and 125, then the cube root of 70 would lie between 4 and 5. So let me find out what the cube root is. We know, we could sense that the cube root of 70 will not be an integer. Right? So 70, the cube root of 70 is equal to 4.1212853 going down the road. All right? So 4.121 da 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 going down the road. See what happening there? Same story here with 5 to the power of 4, 625, the fourth root of 625. We now want to find the fourth root of 689. We show that the fourth root of 689 will not be an integer because the closest integer is 5, right? And the number that will give you a perfect fourth root is 625. The next number in that sequence would be what? 6 to the power of 4. 6 to the power of 4. And the answer for that is 1296. Right. So in other words, 689 being between 625 and 1296, we know that the value of the fourth root of 689 would be somewhere between 5 and 6. Right? We sure it will be greater than 5 because 689 is greater than 625. So we find the fourth root of 689. 689, the fourth root of 689. Is equal to 5.12335 going down the road. 5.123 da 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 going down the road. So in other words, you have what I would call exact roots here. Exact roots derived from what I like to refer to as perfect powers. Right? 2 squared is 4, so the square root of 4 is 2. 4 cubed is 64, so the cube root of 64 is 4. 5 to the power of 4 is 625, so the fourth root of 625 is 5. And then you have other numbers where the root is an irrational number, as we could clearly see. So even if you didn't know what an irrational number was from our previous discussion, just looking at what we're doing here, you get a clear sense of what an irrational number is, what an irrational number could be. Again, I will leave that for the other video that we did before. I'm not going to explain what an irrational number is here. Suffice it to say that in all of these cases here in red, the root is not an integer. So we could call it a non-integer root, we could call it an inexact root, or we could simply say an irrational root. And that essentially is a surd. So the root of 5 is a surd. The square root of 5, right? You know, with the power of 2, we don't really put the 2 there. So the square root of 5, that is a surd. The cube root of 70, that is also a surd. The fourth root of 689 is also a surd. So the concept of surds could apply to any power. However, in regular mathematics practice, the power that we will most frequently use when we're dealing with surds is the power of 2. So we're talking about squares and square roots essentially. So 99% of the work that you will do in an advanced syllabus on surds will be with squares. Alright? Maybe at higher levels in different contexts, you might have to interact with surds like this or like this. So it is important to understand that the concept of surds is not limited to squares and square roots. It just so happens that in regular use, the square and the square root is what we deal with most frequently. And in alignment with that, I want to introduce the concept of the perfect square, because understanding the perfect square is very, very, very important to executing surds properly. So at this point, we will focus more on powers of 2 to fine-tune the discussion a little bit. So let me get rid of these fellas here, and let me stick to powers of 2, because that will be where the majority of the effort will be expended going forward once we're talking about surds. Alright, so we start with the smallest number, of course. 2 squared is 4. Let me play up with some more numbers. Alright, let me say 7 squared is equal to 49. let me say 16 squared is equal to 256. Let me say 27 squared is equal to, I think it's 729 if I'm not mistaken. 27 squared is 729. Beautiful. Yeah? 27 squared is 729. So we choose numbers at various levels, right? Small number, smallish number, slightly bigger number, kind of biggish number. Yeah? Because we want to demonstrate the concept across a range of values. We don't just want to be comfortable dealing with 2 and 3 and 4. And then when I get 14 or 15, you don't know what to do. Right? I just want to take 2 minutes quickly, well, 2 seconds to remind you of the importance of learning your squares and your square roots. Because this topic of surds is a very important topic where that will come into play. Alright? I generally advise my math students to know your squares and squares from 1 to 20. And then my admath students, I would normally advise them to know your squares and squares from 1 to 30. So a little hint there, learn your squares and squares. It will definitely help you in surds. Alright, so back to our good friends here. So in black here now, we have the flip side of that, which is that the square root of 49 is equal to 7. We could say here that the square root of 256 is equal to 16. Or we could say that the square root of 729 is equal to 27. Which means that, alright, I'm marking 4 letters now. Which means that the number 4, the number 49, the number 256, and the number 729 are what we refer to as perfect squares. Alright? Perfect squares. That would simply be the numbers that you learn with the squares and the squares. Let me see if the internet have any definition. I get some really good definitions on the internet, you know. Right? So in addition to the regular textbooks that we normally use, the internet, yeah, you get some really good definitions. And let me see what it's saying about perfect square here. Perfect square. Perfect square definition. Let me see if I like the number, the definition. Okay, they didn't really say much here. Alright. They just describe it as a square number. So essentially a perfect square is a number that you could get by multiplying 2 integers together. Right? The underlying principle behind the perfect square is the integer. It must have an integer root. Alright? So when you learn your squares and your square roots, 2 squares are 4, 3 squares are 9, 4 squares are 16, 5 squares are 25, etc., etc. What you're essentially doing is learning a series of perfect squares. 1 is a perfect square. 4 is a perfect square. The next perfect square after 4 is 9. The next perfect square after 9 is 16. The next perfect square after 16 is 25, and then 36, and then 49, and then 64, and then 81, and then 100. That is 10, right? 10 squared is 100. 121, 144. Those are the 12 perfect squares that most students would generally learn. That thing that they have in the back of the copybook. That's your perfect square. And then of course you go beyond that. 13 squared, 14 squared, 18 squared, 21 squared, 22 squared, etc., etc., etc. So the perfect square is simply one of those numbers that you get when you multiply the integers. Very specific set of numbers, but very useful. Alright, so that is the key. So in other words, the concept of surds enters the picture anytime you're deviating from the perfect square. So once you have the square root, remember we're dealing with powers of 2 now. We're talking squares and square roots. Once you have the square root of a number that is not a perfect square, then that is your surds at the level of powers of 2. So the square root of 5. 5 is not a perfect square. So the square root of 5 is a surd. Alright? 7 squared. The square root of 8. 8 is not a perfect square. So the square root of 8 is something. Root 8 is a surd. The square root of, let me say, 18 as a surd. Let me say the square root of 22 as a surd too. So any number that is not a perfect square, the square root of that number as a surd. So in other words, once you understand the idea and the concept of a perfect square, even without necessarily understanding the concept of a rational number or an irrational number, you know immediately that if you have a number that is not a perfect square, then the square root of that number is a surd. So the square root of 36 is not a surd because root 36 is equal to 6. The square root of 39 is a surd because 39 is not a perfect square, etc., etc., etc. Right? So the whole idea of surds, that is all it is. Knowing what a surd is. Right? Knowing what a surd is, that is the first step. So we're going to take some more steps now. The next step we're going to take is the whole idea of simplifying a surd. So in the same way that we could simplify fractions, in the same way that we could decompose a number or factorize a number into factors, we could do the same thing with surds. So we're going to deal with that in the next video in this series. Stay tuned.